This is Luke Seibold from PhyziX, and these are Newton's 3 laws of motion. So a long time ago, Sir Isaac Newton came up with the 3 laws of motion. And now these 3 laws make up almost everything we know about mechanics. So what you're about to learn is going to be super important. So the first law of motion is that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. Alright, so what exactly does this mean? Well, let's picture we have an ice rink. On that ice rink, we have a hockey puck. The hockey puck is just sitting there, so it's at rest. And it's going to stay at rest until someone comes along and hits it with a hockey stick. And once that force is applied, then it will no longer be at rest, and it will then be in motion. I'm going to show motion with this little vector. And now it will continue with that motion until another force acts on it to stop it. So until, let's say, another hockey player stops it with his hockey stick, and then it'll stop. And so it'll stay in motion until then. But let's say no other hockey player ever touches it, then why won't the hockey puck just go forever? Well, because it's on ice, it will go for quite a while, but that's because ice has very little friction. Now, friction is caused by very small imperfections in the surface of different materials. So let's illustrate that by showing this is the hockey puck on the ice. So here's the puck, here's the ice. That's over here. And because of that, each of these little imperfections is actually pushing back on the puck. And so there is a small force acting against the force that was applied to the puck by the hockey player hitting it. And so this will actually cause the puck to eventually slow down until it comes to a stop. His next law states that resultant force is proportional to acceleration. And this force is actually proportional to acceleration by a factor of its mass. So this gives us the famous equation F force equals mass times acceleration. Alright, so let's say we had a skydiver jumping out of an airplane. Alright, let's say our skydiver is 60 kilograms. And we know that the acceleration due to gravity is 9.81 meters per second. So this little dude's acceleration is going to be 9.81 meters per second squared. Now, if force is proportional to acceleration by a factor of mass, then we get out the famous equation F equals m times a. And so the force that our little skydiver is going to have will be equal to his mass, which is 60 kilograms, times his acceleration, which is 9.81 meters per second squared. And so what that is going to give us is force. His force will be equal to 589 kilograms times meters per second squared. Now, we don't actually use this unit because Sir Isaac Newton came up with all these laws and rules. He actually got a unit named after him for force. So this unit, kilograms times meters per second squared, is actually called the Newton. So when you're measuring force, it's measured in newtons. So the force that our little skydiver is going to have is going to be 589 newtons. And now his final law of motion is that every action has an equal and opposite reaction. So what exactly does this mean? Well, if you've ever given your friend a high five, you know that whether you're the one giving the high five or getting the high five, you're going to feel a slap. And this is because every action has an equal and opposite reaction. So every force has an equal and opposite force. So let's try and pretend that these are hands. Maybe we'll add a little thumb to make it look a little better. It's like kind of nubby thumb. Another thumb over here. So what this means is that the force being applied by this hand in this direction is going to be the exact same force except in the opposite direction of this hand. And so both people are going to feel this force. And this is what it means when each force has an equal and opposite reaction. So both of these forces are an equal, let's say, 3 newtons. So what's pretty crazy about this is that if you were to jump in the air, woohoo, got a little dude jumping in the air, then you would be exerting the same force on the Earth as the force is exerting on you. However, the Earth has much more mass than you do, so it will have a lot less of an acceleration, and we can show this with the following equation. So if F equals ma, let's have this be the force of the Earth, and this be the force of you, Fu. And so if your mass is around 60 kilograms, and the mass of the Earth is actually 6 times 10 to the 24 kilograms, and that means that your acceleration is 9.81 meters per second squared. And so that would mean that the acceleration of the Earth would be equal to 60 kilograms times 9.81 meters per second squared all over 6 times 10 to the 24 kilograms equals the acceleration of the Earth. And so that comes out to being 9.81 times 10 to the negative 23 meters per second squared. So almost nothing at all. And that is why the Earth moves so little, even though you are actually moving it a very tiny amount. So these 3 laws are fundamental in understanding why anything moves the way it does, and can even be used to move planets.